Hey everyone, my name is Adonai McLaren. Today we're going to be talking about VLANs, what they are, why we need them, and how to solve some of the problems that we encounter after we set them up. I put together some labs so we can talk about that and show how to solve those problems. So basically what a VLAN is it's a way to segment the network at layer 2, similar to how we segment the network at layer 3 with subnets. So basically when you first set up a switch and you plug all of your devices into the switch, all of those devices at first are going to be part of VLAN 1. So if we put in show VLAN, here we have VLAN 1. All of these devices right now are currently connected to VLAN 1 because all of these ports on the switch are accessing VLAN 1. So what that means right now is that all of these devices are all in the same broadcast domain. And usually that's a problem because if you're working in an enterprise network, all of these devices probably aren't in the same department in the business. So let's say that these two devices are part of the sales department and they're on the sales subnet 192.168.10.0/24. And this is marketing 192.168.20.0/24. And this is finance 192.168.20.0/24 or .30, sorry. And then this is the IT department 192.168.40.0/24. Okay. Let me just clean this up a bit. So basically the reason why it's bad if all of these devices are in the same broadcast domain is because it eats up resources on the switch. So if PC0 wants to send a broadcast to its subnet, the 10.0 subnet, oops, we ping 192.168.10.255. Just show the simulation here. We send that ping to its subnet 10.0. 10.0 is not the only device that's going to receive that broadcast because when it sends that frame, the broadcast MAC address, that's a FFFFFFFF, that address, when the switch sees it, it's going to forward it all ports because all of these devices are on the same broadcast domain. So if we play the simulation, when switch 0 receives it, it's going to forward it out all ports. The reason why we don't want switch 0 to be forwarding traffic like this, number one, is because it's a waste of resources. It's a waste of CPU and memory resources because PC0, right, it didn't intend for these other subnets to be receiving this broadcast traffic. So that's one reason. The other reason is it's just bad for security. When we set up VLANs properly and we group these devices into the VLANs that they're supposed to be grouped into, they're not going to be able to talk to each other directly. You're going to have to go through a layer 3 device like a router or a multi-layer switch. And then from there, you can involve ACLs, you can use firewalls, and you can filter the traffic however you see fit, depending on the situation. So next, we're going to look at how the network looks when we set up VLANs properly. Okay, so if we open up switch 0 and show VLAN. Okay, so here you can see I've set up these VLANs. We have 10 for sales, 20 for marketing, 30 for finance, 40 for IT. And fast Ethernet 01, 02 are accessing VLAN 10, 03, 04 accessing VLAN 20, and so on and so forth. So basically what happens when we send a broadcast from PC0 to its subnet. All right. So when we send that broadcast, and then switch 0 receives it, it's only going to forward it out to other devices on VLAN 10 because the broadcast domain has changed. Not every device here is on VLAN 1 anymore. Before, every device was in VLAN 1, right? So every device here was in the same broadcast domain. PC 0, 1, 2, 3, 4, 5, 7, 6. They were all in the same broadcast domain with switch 0. Now, let me undo. Because this is in VLAN 10, it's only on the same broadcast domain with PC0, switch 0, PC1, right? So that's a broadcast domain. We also have a broadcast domain between PC2, 3, and switch 0. What a broadcast domain is, it's just a subset of devices that will receive broadcast traffic sent by any of its members. So there's another broadcast domain here and another broadcast domain here. The other thing, go back, just finish this. If we want to send a broadcast to the whole network, actually, let me pull up simulation. If we want to send a broadcast to the whole network, like we're doing now, that's also not going to work because the broadcast domain has changed. And another problem that we have here, if we switch over to real time, if we want PC0, let's check this IP address. We want PC0 to ping PC6 because it's in another subnet. That's not going to work without a layer 3 device. So ping 192.168.40.2. Ping is going to fail. So you can see here, request timed out. If we try again, maybe it was just like an ARP request that didn't finish. It still doesn't work because we don't have a router. So I'm going to be covering inter-VLAN routing next, and I'm going to be showing you 2 ways to set up inter-VLAN routing. All right, we're back. So the first method I'm going to be showing you of inter-VLAN routing is called router on a stick. Basically, everything is set up exactly the same. The only difference is we have this router here, and we're going to need to set up a trunk link between switch 0 and the router. What we could do if we wanted to is set up a link between each VLAN and the router. So we'd have 4 links, but we don't have enough interfaces on the router. So what we're going to do instead is set up sub-interfaces on the router, and then apply IP addresses to each sub-interface, and then set that IP address in each VLAN on those PCs. We're going to set that IP address as the default gateway so that each PC can communicate with the router through its own VLAN. All right, so if we look at the router here, so what you want to do is you want to go into interface config mode, and instead of G00, you're going to want to type in G00 and then dot whatever number you would want to put in. You can put whatever number you want, but best practice is to just put in the number of the VLAN. So you're going to set up a subinterface for G00.10 for VLAN 10, .20 for VLAN 20, .30 for VLAN 30, and then .40 for VLAN 40. You're also going to run a command called encapsulation.1q, and you're going to run that on each interface, each subinterface. You're going to put in the number of the VLAN. So basically, whenever router 0 receives traffic that's tagged with the VLAN 10, VLAN 20, VLAN 30, VLAN 40, it's going to send it to the correct interface. So on .10, on the G00.10, you're going to run encapsulation.1q 10. On .20, you're going to run encapsulation.1q 20, and so on, so on. You can see here. You're also going to run IP address, and then you're going to put on an IP address in the correct subnet for each VLAN. So I just put the last usable address for each VLAN, or for each subnet in each VLAN. So for VLAN 10, I put .10.254, last address in here. For VLAN 20, we put .20.254. So I just did that for each individual subinterface on each VLAN. And then we're going to go over to switch 0. On switch 0, we need to set up a trunk link and then also allow each VLAN to travel on that trunk link. So what a trunk link is, it's basically, it's like a link to another device that allows it to transfer or forward frames to that other device from multiple VLANs at once. What we have here to each PC are access links, so they can only forward not packets, but frames. They can forward frames from one VLAN, but the trunk link between switch 0 and router 0, that allows it to forward frames to router 0 from multiple VLANs. So we don't need an individual access link from each VLAN to router 0, and we can save on interface space on both devices. So if we go to show run on interface F021, we have it configured as switch port trunk allow VLAN 1, 10, 20, 30, and 40, and we have it on switch port mode trunk. One thing you need to remember is that if you're using an older switch, you should run trunk encapsulation, or not trunk encapsulation, switch port trunk encapsulation 1.q, because there are 2 trunk encapsulation methods on older switches. There's ISL, which is vendor specific and only works with Cisco devices. And there's also 1.Q, which is vendor non-specific. So if you want to be able to set up trunks between devices made by multiple vendors, you should use 1.Q. Now that we've gone over that, I just want to test to make sure that we have connectivity between devices on different VLANs. Make sure that we did set up Inter-VLAN correctly. So I'm going to send a ping from PC0 192.168.40.2. That should go to PC6. And we're going to watch that on simulation mode. Let me just make a new scenario so it doesn't play that one. We're going to send our ping. Forward it to switch 0. Switch 0 should send it to router 0. Router 0 sends it back to switch 0, and then switch 0 should send it to PC6. So as you can see, like I explained earlier, since it's on a different VLAN, it does have to route that traffic to a layer 3 device first. Let's try sending that to a different PC. Let's try sending it to VLAN 30. Let me cancel this. So we're going to ping 192.168.30.2. Let me open simulation mode first. Should go to switch 0, router 0, and then switch 0, PC. Oh wait, hang on. That's an ARP. I guess it just wasn't in the ARP table yet. Hang on. Or it wasn't in the MAC address table. You see where it tries the second ping. Okay, there's the second ping. So we're going to send from PC0 to switch 0 to router 0. Should go back to switch 0. And then PC5. Okay, makes sense. So what we're going to go over next is inter-VLAN routing via layer 3 switches and SVIs. Okay, so for the last method of inter-VLAN routing, we're going to be using a multi-layer switch. If any of these devices want to access the outside network, we have a default route set up on the multi-layer switch, and then that goes to router 0, and then router 0 will take care of any packets that need to be forwarded to the outside network, and then server 0 is basically just to represent the outside network. So if we take a look at the multi-layer switch and check out the SVIs, go to enable, show, run. So okay, here we go. So first, what you want to do on a multi-layer switch, you want to run IP routing, and that's just going to enable the switch to have a routing table and perform the inter-VLAN routing. And then from there, you want to go in interface config mode. After you've set up the VLANs, you want to go interface and then type in the VLAN and the VLAN number. And after that, you want to set up an IP address with an IP address in the subnet for that VLAN. So for this VLAN, it's going to be 10.254, kind of like how we did on the router earlier. So you're going to do that for each VLAN, VLAN 20, 20.254, VLAN 30, 30.254, and then 255, 255, 255.0 because it's /24. And then on each of these PCs, you want to set the default gateway to the IP address that you set up on the SVI. And then when it wants to perform inter-VLAN routing and reach any of these devices on the network, it's going to send that packet to the multi-layer switch. And then the multi-layer switch is going to route that to the device using its routing table. because it does have connected links to all of these different subnets here. Show IP route. Because we set up those IPs on the SVIs, we have connected links to each of these subnets for each VLAN. So we have one for the .10 subnet for VLAN 10. We have one for VLAN 20 on the .20 subnet. We have one for VLAN 30 on the .30 subnet. And we have one for VLAN 40 on the .40 subnet. And then basically what we want to do on G10/24, which is connected to router 0, if we want any of these devices to reach the outside network, we're not going to do router on a stick like we did last time, because this is going to be a routed port, and routed ports don't support trunk ports, or don't support trunk interfaces. So we'll run. See what we have here. So we ran no switch port. What this does basically is it just enables layer 3 routing on the port, and then we set up an IP address on that port and an IP, or not an IP, a subnet mask. And then on router 0, we're going to set up a router 0 on G000. We're going to set up an IP address in the same subnet. Hang on. Yeah, on the 10.0.0.0/24 subnet, we're going to set up an IP address on that same subnet with a /24 subnet mask. And then on switch 0, let's take a look at the routing table. Scroll down a bit. We have a default route here, 0.0.0.0/0. That's going to forward any traffic that's not in the routing table. That's going to forward it out of a G1/0/24 towards router 0, and then from there, router 0's routing table will take care of that outside traffic. We have the 10.0.10.0 network connected, so there should be a connected route to that network on this router. So IP route. So we have a connected route to that network. Yeah, right here. And then we also have a static route back to what's actually a supernetted static route back to all of the networks on this multi-layer switch, so that if you send a ping or you send any packets towards router 0 and it needs to send information back, or something outside the network needs to send information into this to this network over here, you'll be able to reach it since it's in the routing table, but it's not connected here, so you would need a static route. That's why we've configured this. Okay, so next what we're going to do, we're going to test for connectivity between devices, just to show you that everything is working and is set up correctly. So we're going to ping from PC 0, 192.168.40.2. We're going to try pinging to the 40 VLAN. Should go to multi-layer switch and then PC 7. And from PC 7 to multi-layer switch, back to PC 0. So it's going directly through the switch this time instead of the router. All right, next what we're going to try is connectivity to the outside network. So we're going to send a ping from PC 2 to server 0. Ping 10.0.10.2 is the IP address for server 0. So we're getting replies back, but let me just watch that in simulation mode so you can see what's going on. So from PC 2 to multi-layer switch to router to server 0. server 0 to router 0, multi-layer switch, and then PC2. Okay, and then one more thing that we're going to try to do, we're going to send a broadcast from PC0. Forgot to show that off in the router on a stick configuration just to show you that the broadcast domains are the same and that the VLANs are set up correctly. So let's play that one. Since the broadcast back stays in its own VLAN. So that's all I have to show you in terms of VLANs. So I'm going to wrap things up there, but I hope everything was easy to understand. Thanks for watching.